Assalamu alaikum students. How are you? I hope you are fine. Learning concepts of math need perseverance, consistent practice. Today our topic is a conceptual topic and that is complex numbers. Complex numbers are new for you. We have already learned about the real numbers. Let's recall that a phenomena related to real numbers. The square of a real number is non-negative. That is, under root 4 is equal to square of 2 under root is equal to 2. When we take square root of a little bigger number, 25, square of 15 is equal to 15. Another number 400, if we take its square root, so it is also equal to a positive number 20. So we come to know that the square of a real number is non-negative, but mathematicians face a problem, and that problem is the solution of any such algebraic equation does not exist, because x square plus 1 is equal to 0. It implies that x square is equal to minus 1. That does not belong to the set of real numbers. That means if we take square root of the both sides of this, we will get what? X is equal to under root minus 1, which will not the part of set of real numbers. So the mathematician tempted to introduce a large set of numbers in which such numbers are included. So define the solution in union of set of real numbers and every number whose square is negative. So that means they include all such numbers which can be written in the form of a fraction like 3 over 5, 2 over 7, 1 over 4, rational numbers. Secondly, they add the such numbers which are written in the form of power like 3 raised to power 1 over 7, etc. Irrational numbers. They also include every number whose square is negative like 3 plus 7 iota, etc. So invention of the new number is the basic need of that time. Mathematicians work on it and they find a solution. They introduce a new imaginary unit under root minus 1 called iota. A Swiss mathematician, Leonard Euler, in 18th century used this symbol iota the first time ever. According to that phenomena, now it becomes possible to find the solution of such equations like x square is equal to minus a to be resolved, to be found. So now this symbol iota square is equal to minus 1 is frequently used in the next exercise. All those numbers which are square root of a negative real number, they are pure imaginary numbers like under root minus 2, under root minus 5, under root minus 7, etc. The numbers like 2 under root minus 1, 3 under root minus 5, etc. These are impure in nature. as a real number is the coefficient of these, that they are impure. Now we discuss the definition of a complex number. A number of the form z is equal to a plus b iota, where a and b are real numbers and iota is equal to under root minus 1. For example, the number of the form like 3 plus 5 iota, minus 4 minus 9 iota. These are the examples of complex numbers. After discussing complex numbers, we now discuss the set of complex numbers, which is a large set of variety of numbers, like we already discussed the rational numbers, irrational numbers, and the numbers, every number whose square is negative. Let's move to the definition of it. The set of all numbers of the form z is equal to a plus b iota, where a and b are real numbers and iota is equal to under root minus 1, which already discussed. Symbolically, in set builder form, that set is written C is a set of all complex numbers such that complex number z is equal to a plus b iota, where a and b belongs to set of real numbers and iota is equal to under root minus 1. The numbers a and b are real and imaginary parts of the complex number. Symbolically, they can be represented as a is equal to re of z and b is equal to im of z, mean a is equal to real part of z and b is equal to imaginary part of z. If we want to understand what kind of numbers are involved, so then recall the phenomena which we discussed in the introduction of this chapter. And that is, in the beginning, we are very familiar about the set of natural numbers, and these are 1, 2, 3 and so on. 0 is another number about which we are well known. When we combine these two, mean natural numbers and 0, so they form a set of whole numbers including 0, 1, 2, 3 and so on. On the other hand, we use negative numbers as well, which are minus 1, minus 2, minus 3 and so on. When we combine these two, when we take the union of these two, mean the set of whole numbers and negative natural numbers, they form integers. And we know that very well, in every integer is a rational numbers. Every integer is a rational number. Rational numbers are also, they are the numbers which are written in the form of a fraction. So all the numbers which are in the form of a fraction, as well as the numbers which cannot be written in the form of fraction, mean irrational numbers. When they are taken, combined, they are written together, they form a set of real numbers. Rational numbers are denoted by q, irrational numbers are denoted by q dash. Whereas when we take their union, mean q union q complement q dash, then that will be equal to what? That will be equal to a set of real numbers. So, in the introduction of this topic, we already discussed the square of real number is non-negative, and in the set of complex number, every number whose square is negative is included. So when we combine these pure imaginary numbers along with the set of real numbers, they form complex numbers. So hence, students, you are now well aware of that. The base of the complex number is that the all pure imaginary numbers, real numbers, whether they are rational or irrational, integers, whole numbers, negative natural numbers or 0, they are complex numbers. Furthermore, there are few properties which we have to discuss for better understanding in the future. What are complex numbers? Every real number is also a complex number. For understanding, every a belongs to R is a complex number, that is a plus 0 iota. where if we take the value b is equal to 0, thus set of real numbers becomes subset of set of complex numbers. But every complex number is not a real number, because R is subset of C, means set of real numbers, subset of set of complex number. Next point which we have to ponder, which we have to keep in mind, pure imaginary numbers, about pure imaginary numbers. In a plus b iota, a complex number z, a plus b iota, if a is equal to 0, then 0 plus b iota is equal to b iota, which is a pure imaginary numbers, belongs to set of complex number. The third point which we have to surely keep in mind, that is complex number 0. Means 0 is also a complex number. In a complex number z equal to a plus b iota, in z is equal to a plus b iota, if a and b both are zeros, then that complex number z will be equal to 0 plus 0 iota is equal to 0, belongs to a complex number. Hence we come to know that 0 is a complex number. So that's it for the concept related to the complex numbers, which is very crucial to understand if you want to understand fully the next following exercises. Thank you.